All right, we're starting our video on chapter 1.4. And as always, when we start by giving you the goal and the learning target for today. We're going to study adding integers. We have some new vocabulary words we've got to cover first. Two numbers with the same absolute value but different signs are called opposites. So a -3 has an absolute value of 3. A +3 has an absolute value of 3. They have the same absolute value, so they are opposites. So -3 and 3 are opposites of each other. An integer and its opposite is called additive inverse. Additive inverse. Key concept, adding integers with the same sign. If I have two integers with the same sign, all I have to do is add their absolute values, and the sum has the same sign as the larger of the integers. Or it has the same sign as the integers, sorry. So here's an example. I have -7 plus -3. They have the same sign, so I can simply add them together. I get 10, and I use the same sign that they had to begin with, so I use -10. Here's another one for you to work on. I have 5 plus 4. They both have the same sign, so I can simply add the numbers together, and I get 9. And I use the positive sign since both numbers were positive to begin with. Add integers with the same sign. Here's another one. They both are negative, so I can simply add them together. 8 plus 4 is equal to 12, and I use the same sign as they had to begin with, so it's a -12. Using a number line to prove it to you. Here's our number line. So it says start at 0, and then move 8 units to the left because it's a negative number. So move from here to 8 because it's negative. From there, move 4 more units to the left because it's also negative. 1 unit, 2 units, 3 units, 4 units right here. Would make it a -12, -12. And that is what we got by doing it the other way. Do this one for me, please. You can either do it on a number line or you can do it the other way. Doing it the other way, I can simply add the 3 plus the 6. I get 9, and I use the sign that they both had of negative, so the answer is -9. Checking on a number line, we move 3 units to the left here, and then we move 6 more units. 1, 2, 3, 4, 5, and 6. And that becomes our answer, -9, so it checks out either way. Adding integers with different signs. Different signs. To add integers with different signs, I subtract their absolute values. Subtract their absolute values, and the sum has the same sign as the integer with the greater absolute value. So here it is. I can subtract their absolute values. -8 has an absolute value of 8. 3 has an absolute value of 3. I subtract them. 8 minus 3 is 5, and it has the sign of the larger one. The larger one was -8, so it has a -5 as its sign. And -5 is the correct answer. Adding integers with different signs. Here's a way to do it on a number line. It will get the same answer, but let's predict what it will be by doing it following the rule. I can subtract the absolute value of the larger one. The larger one is -6. The absolute value is 6. I can subtract 4. The answer would be 2. And then it would have the sign of the larger one. So I'm predicting the answer will be -2. We can start on a number line, and we can go 4 units to the right because it's positive. 1, 2, 3, 4. And then we'll go 6 units to the left because the -6. -6. 1, 2, 3, 4, 5, and 6. So our answer is indeed -2. start at 0, move 4 units to the right because it's positive, just like we said. From there, move 6 units to the left because it's negative, and we do get -2. Please do this one for me. Again, we'll take the bigger number, and its absolute value is 5. And then the absolute value of 3 is 3. We're going to subtract. 5 minus 3 is 2. And we use the sign of the larger one, which was negative. So our predicted answer is going to be -2. I think if you do it with a number line, you'll check it out. And it does work. We move 3 units to the right because it's positive. 1, 2, 3. And then we move 5 units to the left because it's negative. 1, 2, 3, 4, and 5. And it does check out. Adding integers with different signs. Here's another example. -5 plus 9. So the absolute value of 9 is 9. The absolute value of 5 is 5. I subtract. I'm going to get 4 as my predicted answer, and it's going to be positive. +4. Checking that out on a number line, I move -5. 1, 2, 3, 4, 5. And then I move to the right 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my answer is +4. And this is just going through the same exact steps we went through. And yes, it does work out. Here's another one. I'm not going to do this one on the number line. I'm just going to do it since they have opposite signs. I'm going to subtract the absolute value of the biggest one, which was 8, minus the absolute value of the smaller one, which is 6. 8 minus 6 is 2. And we have the sign of the larger one, which was positive, so we think it's going to be +2. If we check it out on a number line, I go 6 units negative. That's right here. And then I move back 8 units to the positive side. 1 unit, 2 units, 3, 4, 5, 6, 7, and 8. And it does come out, does check out to be +2. Adding integers, another example. This one's too big for the number line. The number line that would contain these two numbers, way too big for us to do. So we're forced to use it using the method of absolute values. So we'll be working with the absolute value of -33, which of course is 33, and the absolute value of 16 is 16. I'm going to subtract one from the other. 13 minus 6 is 7. 2 minus 1 is 17, and I use the sign of the larger one. So my predicted answer is -17. They did the same steps there, and the same steps here. And they are saying the sum is going to be negative. And the answer is -17. Okay. Here's find 25 and -5. We're adding 25, I'm sorry, and -15, 25 and -15. The absolute value of 25 is 25. The absolute value of -15 is 15. Subtract one from the other, I get 10, and I use the sign of the bigger one, so it's going to be a +10. +10. So if I move this way, and the number line is too big for our number line, but if I move this way 25 units, and I come back here 15 units, I'm going to get to the number 10. Now we're going to talk about another property that we all need to learn. It's called the additive inverse property. Saying that in words, the sum of any number and its additive inverse is 0. There's a couple of examples. One dealing strictly with numbers, and I think you'll see this one's pretty easy. 7 plus a -7 cancels out. You get 0. Same thing can be said in algebra using variables. X plus a -x equals 0. That's called additive inverse. We're going to do a little bit more work with adding 3 or more. We're going to be adding integers, but this time we're going to be dealing with 3 or more numbers. And we're going to do a little bit of grouping to make this easier. We're going to work with the associative property. We're going to change the grouping. And where you can see we're actually going to group the -5 and the -3 together. I chose to do that because they have the same sign. And when they have the same sign, you know that I simply add them together and use the negative sign, or use the sign that they have. So now I've got 2 plus a -8. And I can go 2 plus a -8 or -6. Checking your progress. Find 3 plus -6 plus a -2. Again, I'm going to do a little bit of grouping using my associative property. I'm going to group those two together. So that becomes 3 plus -6 plus -2 is 8. I add the two integers together, get 8, and I use the sign, so it's a -8. 3 plus a -8. I take the larger one, the absolute value of the larger one, 8, minus the absolute value of the other one, which would give me 5, and I use the sign of the bigger one, so it would give me -5. Real world example here. An investor owns 50 shares of a video game manufacturer. A broker purchases 30 more shares for him on Tuesday. On Friday, the investor asks the broker to sell 65. How many shares will this stock will the client own after the trades are complete? Well, I'm going to start here. I'm going to say he starts off with 50. He buys 30 more, so that buying is adding, so that's going to be plus 30. And then he's going to sell 65. I'm going to group them to make it a little bit easier. 30 plus 50 is 80. And this could be 80 then minus the 65. 80 minus 65 is 15. Selling the stock will decrease the number, so it's a -65, and that's what we thought. Purchasing the stock will be a positive 30, and that is what we thought also. Add these integers to the starting number of the shares to find the new number, and we do find out when we're all done, the answer is 15. I guess a couple of slides here for you. Oh, this is the same problem we just did. We're going to use the associative property to group them. Then we're going to simplify. $80 minus 65. And the answer is 15, so our work does check out. Jamie gets an allowance of $5. She spends $2 on video games, $1 on lunch. Her best friend repays her $2, and she buys a $3 pair of socks. How much money does she have? So she starts off with 5. She spends 2. Then she spends another $1. Then she gets $2, and she buys $3 worth of stuff. So I think if we write this out, we can say she started out with 5. By spending 2, you got to subtract the 2. By spending 1 for lunch, you got to subtract 1. Then she gets a repayment of 2, so that would be plus 2. And finally, she buys, so that means it costs her money. She's got to pay the $3. So let's try and do this on a number. Well, we could group these like that. And we could say 5 minus 2 is, of course, 3. Then minus 1 plus 2 minus 3. 3 minus 1 becomes 2, plus 2 minus 3. 2 plus 2 becomes 4 minus 3, and the answer works out to be $1. Let's check it on our number line. All right, so we were predicting our answer to be the number 1, but let's start off. She starts off with $5. She then spends $2 on lunch, so that would be $2 this way, $1, $2, so she now has that much. Then she spends another dollar on lunch, so it goes down even further. At that point, her friend repays a $2 loan, so she gets positive 1, 2. She's back up to here. And then she buys a $3 pair of socks, so it's got to go down by 3. 1, 2, 3. She's got $1 worth of her allowance left, so it does check out.